Okay, so today I'd like to talk to you about the buoyant force. This is our first new force for the year. And I want to make sure you know some basic properties of the buoyant force. So when does the buoyant force come into play? The buoyant force happens anytime an object is partially or fully immersed in a fluid. So if we have an object and we place it in water, whether or not it's fully submerged or partially submerged, there will be a buoyant force on that object. It does not have to be water. It could be any fluid, including gases. If an object is in a fluid, it experiences a buoyant force. Another property of the buoyant force is that the buoyant force always acts against gravity. So the buoyant force would be pushing up as gravity is pulling down. What causes the buoyant force? Well, when you have an object in a fluid, there is fluid pressure in all directions. There's pressure on the top pushing down. There's pressure on the bottom pushing up. There's pressure on the left pushing right. And there's pressure on the right pushing left. There's pressure from the front pushing backwards and from the back pushing forward. So we have pressures in all directions. And you might think that because of that, all the pressures would cancel out and there'd be no net effect. Well, that turns out not to be quite the right case, because the pressure pushing down and the pressure pushing up are not equal. Why are they not equal? Because the pressure is greater as you go farther down in the fluid than it is when you're not as far. So these two, the right and the left pressures, they do cancel. There is no net force or pressure right or left or forward or backwards, but there is a net upward force because the pressure on the bottom is always greater than the pressure on the top, because the pressure on the bottom is caused by a deeper depth below the fluid. Okay, so that is the origin of force buoyancy. Make sure you understand it and you have it written down, that buoyancy is caused by a difference in pressure between the top and bottom of the object. The pressure on the bottom is always greater because it's deeper, and the pressure on the bottom pushes up. So buoyancy is always going to act upward. Realize the buoyancy is caused by the pressure, and the pressure is caused by gravity. So buoyancy could not happen without the force of gravity initiating it by creating this pressure difference. Okay, now that we know what causes buoyancy, let's look at the factors that affect how strong the force of buoyancy is. It turns out that there are three factors. One, the type of fluid that it's in. Two, the planet's gravitational field. Why is that a factor? Well, we saw that buoyancy was caused by fluid pressure, and fluid pressure is influenced by the planet's gravitational field. So we have density of the fluid, gravitational field, and the third factor is the volume of the object that is actually under the fluid. It's called the volume submerged. So the equation looks like this. Force buoyancy, density of the fluid, gravitational field, volume submerged. Okay, so now that we know the formula for buoyancy, how do we know if an object's going to float or sink? Well, in most cases, objects are going to have two forces on them when they're in a fluid. Obviously, we're going to have force gravity. We always have that when we're on a planet. And in addition to force gravity, if you're in a fluid, you're also going to have a force buoyancy. So we look at these two forces and see which of the two dominates. If it turns out that the force of gravity is greater than the force of buoyancy, then the object is going to sink. I hope that makes sense. Gravity bigger than buoyancy, it sinks. If, on the other hand, buoyancy is bigger than gravity, not only does it not sink, but it's going to rise up through the fluid. We have more force pushing up than we do pulling down, so the object rises through the fluid. The only time the object doesn't rise or sink is if we have buoyancy and gravity equal to each other. And under those conditions, it's said to be neutrally buoyant. It will not rise, it will not sink, it will remain wherever it happens to be. So if we put an object underwater and buoyancy is bigger, it rises up through the fluid until eventually part of it comes out of the fluid, making less volume submerged until we reach a point where buoyancy and gravity are equal, and at that point it will no longer rise or sink, it will float. Okay? So the object floats when buoyancy equals gravity. Okay, here is a slide showing you the discoverer of the force buoyancy. It was Archimedes. You can see it was a long time ago, and his discovery took place in Syracuse, not in New York, but in Sicily, okay, way back around 220, give or take, BC.